We'll be trying to graph radical equations today. So far we've been simplifying them, but now it's time to take a look at what would a graph look like. So whenever we don't know how to graph something, our fail-safe is to go ahead and make a table of values. And we generally want to know, well, where is our vertex? Now in the case of a radical, we don't really have a vertex, but we do have a place to start. But what is that place to start? Well, when we did absolute value, and I'll write it down here, we had something like this. If we had something like this, like x plus 5, absolute value minus 7, we would know to start at the point -5, -7, and that ended up being our vertex. Whatever's inside our function with the x, we switched its sign. That gave us the x-coordinate of our starting point, and then whatever number was hanging on the outside, that was our y-coordinate. We just had to remember to switch the sign for the one that was with x. In this case, we don't see anything inside with x, nor on the outside. So we believe our starting point is 0. And if I put 0 in here, the square root of 0 is 0. Now usually for our vertex, we put it in the middle, but I'm going to show right here. What if I did square root of -1? And if I type that into my calculator, I'm going to get an error. That's because I'm not going to be able to do the square root of -1, at least not getting a real number. So we don't have anything here. So we're not going to need to worry about anything mirroring or anything like that. So let's go ahead and go to the right one, and if we do the square root of 1, that's 1. If we put in 2, let's go ahead. Let's find out. If I put in 2 and I square root that, I get 1.41. I may not want to actually use this number, but I do get it. And if I try 3, and I square root the 3, I get 1.73. And if I try 4, that's going to be the next one that works out. The square root of 4 is 2. So I have a few points here, so let's go ahead and try it. So if I graph 0, 0, I graphed this one, 0, 0, that's what I get. Now I graph 1, 1, x is 1, y is 1, that's right here. For now, I'm just going to skip these two. You could graph them, there's nothing wrong with that. I'm going to go to the next one that worked out, which is 4. So x is 4, 1, 2, 3, 4, and y was 2. Well, this doesn't look like very much information to graph. In fact, if I continued my table and I did 5, 6, 7, 8, all of these are going to give me decimals. So there's nothing wrong with graphing a decimal. But what about 9? If I do square root of 9, I get 3. So let's do the 3. So 4, this was 4, 5, 6, 7, 8, 9. Square root of 9 is 3. That's looking better to have points to graph. So I'm going to connect those points. Nice smooth curve right here. It should still be going up. But that's my graph. I don't have this thing. I don't have another side. Just the one side. So let's see if we can take this and graph a little bit of a different one. Here's square root of x plus 3. Now I want you to be thinking, what happens to my original graph? What do I mean my original graph? Well, my original graph was y equals square root of x. This is called the parent, because all of these are going to be based upon the square root. It's going to be based on this one. And what we're actually going to do is what's called a transformation. We're going to move that somehow. All right, let's do a table of values. So where do I expect to start? So using the same concepts as my absolute value, and I'm actually going to write this down here, our square roots have this form. Y equals a square root x minus h plus k, where h comma k is going to be where we start. That's similar to absolute value, which had this form. I don't think we ever really wrote this form down other than to say that we had a vertex and we treated the a as a slope. Now, we will be doing a number in front here, but it's not going to be a slope. All right, so what's our starting point for this one? Well, 0, 3. Now again, I don't really need to put this one in the middle of my table, although I could. I'm just not going to have any negative values of x that's going to work. And I start filling this in, 1, 2. I'm going to continue it over here. 3, 4, and so on. And I'm actually going to get similar numbers out as I did before. So if I do the square root of 1 and then add 3 to it, I'm going to get 4.1 something. If I do the square root of 2 and I add 3 to it, I'm going to get like 4.7. If I do the square root of 3 and then add 3 to it, I don't remember what I put in there. But then if I do the square root of 4, that's 2. Add 3 to it, I get 5. I don't know what that one is. If I jump down, if I do the square root of 9, the square root of 9 is 3, and I add 3 to it, I get 6. So let's graph our starting point. Our starting point is 0, 3. And I'm going to go ahead and graph this point because that came out easy. Oh, I skipped, I did this wrong. Square root of 1 is 1, add 3, that should be 4. My bad. This is off 1. Got it off 1. Alright, so I do have this next point is right here. The point 1, 4. And then the next point that came out good was the point 4, 5. 1, 2, 3, 4, 5. It's right here. And the next one that comes out nice is 9. 5, 6, 7, 8, 9. Right here. Now, if I compare this to my other graph, which I'm actually going to show it, look what happened. It went up, didn't it? And let's take a look at our equation. Oh, look. There's a plus 3 right here. So it went up. All right, let's do this one. So what do you think is going to happen? If I put in x, y, this is an xy table. My start point is what? 0, negative 3. I don't need to worry about negative values for x because those aren't going to work. If I put in 1, the square root of 1 is 1, and then minus 3, negative 2. I'm going to skip 2 and 3. If I put in 4, the square root of 4 is 2, then minus 3 is minus 1. So I think that's good enough. So here's our starting point, 0, negative 3. Then I'm just going to put in all these points. Oops, right there. And then the next one is going to be right here if I did 9. Connect. All right, and let's compare that to our original. Looks like it went down, but by how much? Looks like it went down 3 units. Okay, let's just continue. Now I'm going to be doing shorter tables. So now I put the 3 on the inside. So what's our start point? Not 0 something. Negative 3, and don't have anything out here, so negative 3, 0. That's where I'm going to start. So I have my table. Negative 3, 0. I'm going to go to the right, so negative 2, negative 1, 0, 1, and so on. All right, if I put negative 2 in, I'll do some work over here. So if I put negative 2 in for x, I add 3. Do the inside first, square root of 1, which is 1. All right, if I put in negative 2, if I put in negative 1, if I put in negative 1 plus 3, so I'm putting it into here, I get square root of 2. And the square root of 2, let's go ahead and do that. 2, we'll square root it, 1.4. So get 1.4 right here. If I put in 0, that's going to be 0 plus 3. So square root of 3. If I put in square root of 3, I get 1.7. If I put in 1, that's 1 plus 3. It's inside the square root, which is 4. Square root of 4 is 2. And we'll just go on from there. Keeps on going. So negative 3, 0 is right here. X is negative 3, y is 0. Negative 2, 1. That's right here. And negative 1 and 1.4. I'm not going to graph these two, but you could. Nothing wrong with that. I'm just going to graph the ones that come out easy. I'll graph these that come out nice. All right, there's another point. And we'll draw that. Now let's think, what happened compared to my original? Looks like it moved to the left. Went left 3 units. Okay. What if I did this one? What's our start point? 3, 0. Make my table. So 3, 0 starts. I don't need the top part. Why? Because I know that that's going to give me negative values in here, and I'm not going to be able to square root those. So I get 4, 5, 6. So 7. I'm not going to, if I put in the 4, that would be 4 minus 3, which is 1. Square root of 1 is 1. I'm not going to bother with these two. You can, but I'm not going to bother with them. If I put in 7, 7 minus 3 is square root of 4. Square root of 4 is 2. So I have enough points here. So I have 3, 0, 4, 1, and 7, 2. That's this point. And you really should be catching on to a pattern that is emerging for these. All right, let's compare that to our other graph. Looks like we moved to the right. All right, so what is going to hold true here? Well, let's do a couple more. We'll see. So this time I have a number in front. Now, when we did absolute value, this was a slope, but not anymore. It's going to be something else. It's going to be a stretch. And actually, even our slopes are stretches. It's just easier to use them as a slope. This is a stretch. So if we have x, y, what's my starting point? 0, 0. This 2 does not influence my starting point. So I start at 0, 0, fill in my table. 1, 2, 3, 4. I'll stop at 4. So if I put in a 1, that would be 2 square root 1. Square root of 1 is 1, so I get 2. 2. If I put in 2 or 3, I'm going to get decimals, but I'm going to go ahead and do that. So if I put 2 square root of 2, so I have to do the square root of 2 first, did it, now times 2 more, 2.8. Now if I do 3, that's going to be 2 square root of 3. So I have to do the square root of 3 first. There's my square root of 3, but then I have times 2 on the outside. I get 3.46. Around that to 3.5. And the last one, if I do 4, I have 2 root 4. The square root of 4 is 2, so I have 2 times 2, which is 4. So this is 4. I'm going to graph these. I'll ignore these, but you could graph them. Nothing wrong with that. So 0, 0, 1, 2, and 4, 4. Now connect these dots, and notice it seems that my graph got taller, right? This should be nice and curved. In fact, if I compare it to the first graph, It looks like each point is twice as tall. Let's try the half. So I expect it to shrink this time. So my start point is 0, 0, x, y. And I'll put my start point. 1, 2, 3, 4. So if I put in 1, I have a half square root 1. So that's a half of 1, which is 0.5. So 0.5 right here. I won't bother with those two. If I do 4, I get half the square root of 4. The square root of 4 is 2, so a half times 2, that's over 1, so 1, so 4, 1. So I'll graph these 2 points and this point. So 0, 0, that's right here. 1 and a half, that's like right here. And then 4, 1, that's right here. And notice it's very smushed. In fact, if I compare it to the original graph, it looks like it's half as tall. Oop, I want this one. Okay, so I hope you're getting the point here, but let's try graphing this one. In fact, I'm going to put a 2 right here. I'll make it even harder. Why just a 2? Maybe something larger. Maybe a 3. I'll put a 3 right here. So what's my start point? Where am I going to start? Well, I'm going to start at -4, 5. Now this time, I'm going to do it without a table of values. And if you can follow along with that, now you certainly can use a table of values, in which case I would put -4, 5 right here, and I'd start putting in these numbers. And you can use all of these, it doesn't matter, but I'm going to start using a trick. So I'm going to start at -4, 5. So 1, 2, 3, 4, 5. In fact, I'll make this a -3. Want to make this a -3? Let's make it a -3. So 1, 2, 3, 4. Then 1, 2, 3, 4, 5. All right, here we go. So there's my start point. Now again, you can use your table of values. I'm not going to. I'm going to do everything in my head, and here's how I'm going to do it. First of all, I'm going to always start at the start point. And I'm going to say to myself, if I go right 1, what's my parent function? My parent function is a square root. So if I go right 1, I'm going to square root 1. And what's the square root of 1? Well, 1. But I have this number in front of it, that's my stretch. So I'm going to multiply that times -3 and get -2. So if I go right 1, that's like putting in a 1, and I'm going to go down. Am I dumb? 1 times 3 is 3, not 2. My bad. I'm going to go down 3. Now I notice, now what I just said there is not what you have in your table. In our table, what are we putting in for x? We're putting in -3. And if we put in -3, I'll show all the work right here. -3, I have a -3 out here, plus 4, plus 5. I have -3, square root of 1, plus 5. Square root of 1 is 1. -3 plus 5 is -2. And I get this point, -3, -2. Look at where this point is. It's -3, -2. It's in the same spot. All right, let me continue with the trick. If I go right 2, I'm not going to be able to do the square root in my head. If I go right 3, from my vertex or my starting point, I'm not going to be able to do that square root. If I go right 4, though, I can. So I'm thinking in my head, if I go right 4 from my vertex, what's the square root of 4? 2. Okay, but I have a stretch. My stretch is -3. So I times that by -3. I get -6. So if I go from my starting point, if I go right 4, square root of 4 is 2, times my stretch of -3, that's -6. So I'm going to go down from where I'm at, I'm right here, down 6 units. 1, 2, 3, 4, 5, 6. Okay, I'm going to go back here. If I go right 5, can't do it. Right 6, can't do it. Right 7, can't. Right 8, can't. Right 9, however, square root of 9 is 3, and 3 times negative 3 is negative 9, so I'd go down 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. This is my other point. And I'm getting points that work very nice. And now I can connect these. And there we go. All right, let's summarize it, then I'll do one more example. So, our parent function is y equals square root x. My start point H and K are just letters representing something that I'm going to move this. My start point is going to be HK, whatever it is. So for example, let me give you two of them. If I do y equals square root x plus 7 minus 3, I'm going to start at negative 7, negative 3. And if I give you this, y equals square root x plus 4 plus 7, I would start at negative 4, 7. Switch the sign of the thing on the inside. Let me give you a third example. If I give you 2 square root x minus 5 plus 3, I'm going to start at 5, 3. Switch this sign on the inside. So that gives me my start point. The letter in front is my stretch. So you could either use the trick that I just showed you, or use a table of values. It doesn't matter. So for this final example, I'm going to do the trick. I'm not going to bother with the table. So let's say I want to graph x minus 2 plus 3. So I'm going to graph the point 2, 3, because that's where I'm going to start. 2, 3. That's right here. Now, from this point, if I go right 1, the square root of 1 is 1. So I'm going to go up 1. I go back to my start point. Always go back to your start point if you're using the trick. If I go right 2, can't do the square root. Right 3, can't do the square root. Right 4. Now I can do the square root. The square root of 4 is 2. So up 2. There's no stretch on this one, so I don't need to worry about that. Right 5, can't do it. Right 6, can't do it. Right 7, can't do it. Right 8, can't do it. Right 9. The square root of 9 is 3. So up 3 from that spot that I'm at. And what you should see is all these points that I just did match up with our table of values fine.